I'm going to talk about the arithmetic series formula. I'll assume that you know what an arithmetic sequence is. I'll also assume that you know what an arithmetic series is. If any of those topics is unfamiliar to you, I would invite you to watch the necessary videos. All right, let me continue. I'm going to start with a story about the famous mathematician named Gauss. When Gauss was a young boy in math class, his math teacher gave the class the following exercise to kill some time. He asked the class to calculate 1 plus 2 plus 3 plus 4 and on, all the way to 100. Now, every student had a little portable personal chalkboard. So the students started furiously adding numbers to try to calculate the sum. And Gauss, not doing apparently any work, just calmly wrote his answer on his little personal portable chalkboard and turned it in. Later on, it was discovered that Gauss had the correct answer. All right, now how did Gauss get the correct answer without apparently doing any work on his little chalkboard? Okay, well, this is what Gauss apparently did in his head. So he thought about what would happen if I wrote the sum backwards below the first expression of the sum. All right, and now what would happen if I added up the numbers in different rows? So the first row has a 1 and a 100. So if I add those, I get 101. The next row has a 2 and a 99. If I add those, I get 101. And this will continue, and I will keep getting 101. All right, and so apparently I can find the original sum by summing up a certain number of 101s. Now, what I've written there, I have 100 101s, but that represents double the sequence because I've written it twice. So I can divide that by 2 to get the correct answer for the original sequence. So that's equal to 50 times 101, which is equal to 5,050. And that's what Gauss got, and that's the correct answer. So this is an example of an arithmetic series. And what Gauss did was he found an arithmetic series formula for a specific arithmetic series. Now you can see why many consider Gauss to be the greatest mathematician who ever lived. Now what we're going to do is we're going to derive an analogous formula for any arithmetic series. Okay, so let's do that now. So every arithmetic series has a first element. Let's denote that by a sub 1. And the next element is a sub 1 plus d, okay, for some d. And if it's an arithmetic series, then the next element will be a sub 1 plus 2d. And the next element a sub 1 plus 3d. So this will continue to the nth element, which is a sub 1 plus n minus 1d. Now, the reason that this will hold is the reason that every arithmetic series will have this form is because every arithmetic sequence has elements that are the same, that are equal to the same number added to the previous element. Okay, so let me write the series backwards underneath. All right, and once again, let's add the rows together. So the first row, I have an a sub 1, and then below it I have an a sub 1 plus n minus 1d. So summing those, I get 2 times a sub 1 plus n minus 1 times d. And then the next row, the sum will be 2 times a sub 1 plus, when I simplify, n minus 1 times d. And so this pattern will continue, and then the last row will give 2a sub 1 times n minus 1 times d. Okay, and so I have n equivalent expressions, and so the original sum is n times 2 times a sub 1 plus n minus 1 times d all over 2, right? And notice that the expression inside the parentheses is equivalent to a sub 1 plus a sub n. Okay? So that is our arithmetic series formula for the first n terms, where the first element or first term is denoted by a sub 1, and then the next term is a sub 2, and so forth all the way to a sub n. All right? So that's an important formula that you'll want to remember. Now, let's use that formula in an example. Suppose we wanted to calculate 1 plus 5 plus 9 plus, and then we'll continue the pattern all the way to 53. So this is an arithmetic series because every element is 4 more than the previous element. We need to figure out how many elements are in this series. We can determine that easily by finding the function that describes the corresponding arithmetic sequence. And so that's a sub n equals 1 plus 4 times n minus 1. So let's see what number n corresponds to 53. So 53 is equal to 1 plus 4 times n minus 1. Subtract 1 from both sides, so 52 equals 4 times n minus 1. Divide both sides by 4, so 13 equals n minus 1. So n is equal to 14. So we're adding 14 terms. So using our formula, 14 divided by 2, add the first element to the last element, and that's equal to 7 times 54, or 350 plus 28, which is 378. Okay? Now suppose instead of being given the series, you were given the function that corresponded to the arithmetic sequence, such as the following. A sub n is equal to n over 2 plus 1. And suppose we wanted to find the sum of the first 35 terms in the corresponding arithmetic series. Okay? Well, we can create the first few terms of the series. So for n equals 1, we would get 3 halves. For n equals 2, we would get 4 halves. Okay, so here's the series, and so the last one will be 37 over 2, the last element in the series. So using our formula, we have, let's see, 35 terms, so 35 divided by 2 times 3 halves plus 37 halves. That's equal to 35 divided by 2 times 40 over 2, which is equal to 350. Now, I would like you to try using the arithmetic series formula. Would you please try to calculate 1 plus 4 plus 7 plus 10 and so forth? I want you to find the sum of the first 10 terms. Okay? So pause the video and do that now, please. Okay, so I'll go ahead and work it out also. So the function that represents the corresponding sequence is a sub 1 plus 3 times n minus 1. So the 10th term is 1 plus 3 times 10 minus 1, which is 1 plus 3 times 9. 27 plus 1 is 28. So now we can use our formula. 10 over 2 times 1 plus 28 gives 29 times 5, or 100 plus 45, or 145. Okay? Now I'd like you to do one more. This time I'm going to give you the function that describes the arithmetic sequence. A sub n is equal to 5 minus 3n. I want you to sum the first 5 terms using the arithmetic series formula. All right, so pause the video and do that now, please. Okay, I'll go ahead and work it out. So 2 plus minus 1 plus minus 4 and so forth. So the 5th term is 5 minus 15, which is negative 10. So 5 divided by 2, 2 plus negative 10 gives 5 halves times negative 8, which gives minus 40 over 2, which is negative 20.